Hey guys, I'm back with a new video. In this video, let us learn about how we can remove a node at some specific index in a linked list. So removing a node at some specific index. Now the user will give us an index at which we want to remove a node. So the very first step for this method is to check whether the user provided a valid index or not. So if the index that the user gave us is negative, or if the index is greater than or equal to the size of the linked list, then we can simply say index is out of bounds. Now let us consider the case when the size of the linked list is 0. In that case, you are having no element in the linked list. So if you are not having a node in the linked list, you cannot remove any node from the linked list because practically the linked list is empty. So it is the case of underflow, and we can simply return -1 in that case. Now let us move forward to the case 2 where size is 1, and these two cases are exactly the same that we had discussed in the previous two videos regarding removal of a node. So if size of the linked list is 1, that is we are having a single node in the linked list which has a data d, for example, and the head and the tail both are pointing to that single node. So the steps for removing this single node of our linked list is to first set the head and tail to null. So the pointers are now no longer present on our node with data d because now they are set to null. So now we have this configuration, and then we have to set the size to 0, which means that now our linked list is empty because it no longer contains this node, right? Now let us consider the case 3 where the size of the linked list is more than 1. So if the index that the user gave us is a valid one, we can proceed with the deletion of the node at the index that the user gave us. So let us first consider a linked list. So 1, 2, 3, 4, 5 and 6, and currently our head is at this point. Now let us say that the user wants to delete a node that is sitting at index 2, which is 3. So our indexing is starting from 0 and goes till 5. So we want to remove this node that is sitting at index 2. So the very first step is to find the node that is sitting at an index 1 less than the index at which we want to do a removal, that is 2 minus 1. So an index which is 1 less than the index at which 3 is sitting. So 3 is sitting at index 2. So if you do 1 less than this, we get 1. So if we make use of the getNodeAt function that we defined in the previous videos, to get the node that is sitting at an index 1 less than the index at which 3 is sitting, we will get this node, which is 2, right? And at this node, we can set up a reference, and let us name this as prev node. Now the next step is to get the current node that we want to remove, and we can get the current node by saying current node as the next of the previous node, right? Previous node is currently pointing at this node. This is a reference pointing to 2, and if you do the next of prev node, then you will get 3, and let us set a reference of current node to 3. So this is the current node, and let us also get the next node of the node that we want to delete. So 3 is the node that we want to delete, and the next of this node is 4. So we can set up a reference here by saying next node, which is the next of the current node. So the next of current node, which is 3, is 4. So we can set up a reference of next node on the node which is 4, right? So now we have our references in place. Let us perform the deletion now. So our current configuration is something like this: 1, 2, 3, 4, 5 and 6. Our current node reference is pointing at 3. Our previous node reference is pointing at 2. And the next of previous node gives us the current node. The next of the current node gives us the next node. So the next node reference is at 4. And the indexing that we are having is 0, 1, 2, 3, 4, 5. So now let us focus on the deletion part of this case. The very first thing you need to do is you need to set the next of the previous node to next node. So the next of the previous node is this link. We have to set this to the next node, right? So how we can do this? Simply detach this link, and the link that is coming out from 2 should now point to the next node like this. Okay, so the first step is done. Now you can see that the next of the current node is pointing to the next node, right? So ideally we should set it to null so as to decouple this node from our linked list completely. So we have to remove this node. But then you don't need to explicitly set it to null in Java, because in the end this reference, which is current node, will get garbage collected using the mark and sweep algorithm that Java uses. So this entire node will get garbage collected. So garbage collection. Now once we are done with this process, you can see one node is no longer present in our linked list. So the size of the linked list will get decremented by 1. So initially the size was 6. Now it will become 5. And then whatever data that we have in the node being pointed to by current node reference, we can return that, which is 3. So 3 is the data of the node that got removed. And this is how we perform deletion of a node at some specific index lying within the bounds 0 to 5 for this linked list, or for 0 to the size -1 for any general linked list having size number of nodes. So finally our linked list looks something like this. So now we have 5 nodes, 1, 2, 3 is gone, so 4, 5 and 6. Indexing starts from 0, 1, 2 and goes till 4. So now let us head over to our editor and code this out. So right here, let us define the method to remove a node at some specific index, and let us take this index as IND. Now the very first step for this method is to check whether the user provided a valid index or not. So if the index is less than 0 or it is greater than equal to the size of the linked list, then the index that the user gave us is out of bounds, and we can simply return -1, indicating that the removal cannot be done. So let us leave a message here, index out of bounds. Now let us consider other case when the size of the linked list is 0. So if size is 0, we can simply print to the terminal underflow and return -1 here as well. Else, if the size of the linked list is 1, then we can delegate the responsibility of deletion of that single node to the handle one size removal function that we had defined in the previous videos. Lastly, if the size of the linked list is more than 1 and the index that the user gave us is a valid one, let us proceed with the deletion of node using the procedure that we had discussed in this case. Now let us first find the node that is sitting at an index 1 less than the index at which we want to remove. So we basically want to find out this node which is at index 1 less than the index at which we want to remove. We want to remove at index 2. So 1 less than this is 1. So we want to find the prev node now, right? So here we can say node prev node and use the get node at function, pass on the index at which we want to remove, and to get the previous node we need to pass in the index that we got -1, right? This gives us the previous node of the node that we want to delete. Now to get the current node that we want to remove, we can say node current node, and let us set this to the next of previous node. So now we also have a reference to the node that we want to delete, which is being pointed to by the current node reference. And let us also get the next node of the node that we want to delete, which we can get by saying current node dot next, and let us set this to next node. And finally let us set the next of the previous node to the next node, previous node dot next, set that to next node. And these are all the steps that we had discussed just a while back, and this is how we link the previous node to the next node, right? And now you can see that the current node's next is pointing to the next node, so we can set it to null to decouple it from the linked list. But then, as I already explained, you don't need to explicitly set it to null in Java, because in the end this reference current node will get garbage collected using the mark and sweep algorithm that Java uses. Now the next step is to decrement the size of the linked list by 1, so size minus, because now we have just deleted one node from the linked list. And now let us finally return the data of the node that we just removed. So return current node dot data. And now let us finally try this method by running it down below. Linked list dot remove at index 1, and then let us display the linked list as well. So let us compile the code and run the file. So java c linklist.java and java linked list. So here you can see on line 165 Our present linked list looks something like this: 2, 7, 3 and 4. Now we executed the operation remove at 1, so 7 is now gone, and you can see we are getting 2, 3, 4 as the output. So this was all I wanted to cover about removal of node at any position in the linked list. So let's catch up in the next video where we will discuss how we can reverse a linked list in Java.